Okay, my friends, amazing. NASA just proved electron flood theory, supported it, let's put it that way. I am saying that as the Earth spins or as the Sun spins, its magnetic particles in its atmosphere scrub through the ether in space, creating magnetism, concussion, heat, energy. Now, NASA, this is August 7th, this is just a couple of days, or even a few days ago. NASA sounding rocket finds helium structures in Sun's atmosphere. Well, there's helium, but guess what? It only collects in the bands outside of the equator. I'm going to explain it to you. So in other words, there's no helium in the equator. And then there's a high concentration up here and a high concentration there. Why is it not here? The sun spins, the sun pushes through the atmosphere. As it does, the heavier particles of helium, which impact harder with the scrub, are forced up and out away from the center. The lighter particles collect towards the center. The heavier ones get pushed away because they're impacting harder. It's as simple as that. So you get a heavy dense region of helium here and a heavy dense region of helium here and none in the center. Let's see what they say. Helium, the second most abundant element in the universe after hydrogen. Scientists aren't sure just how much there actually is in the sun's atmosphere. Hard to measure. Knowing the amount of helium in the solar atmosphere is important to understand the origin, acceleration of solar wind. Well, let's just cut to the chase. If you come down here, it says Herschel's observation showed that helium wasn't evenly distributed around the corona. Why not? It says the equatorial region, right around the center equator, had almost no helium, while the areas at mid-latitudes, which are these areas, mid-latitudes here and here, at mid-latitudes, where was I? While the areas of mid-latitudes had the most, because they're being pushed. It's coming scrubbing this way and it's saying push away, get out of the way, get out of the way, get out of the way, and that's all it is. And they have no clue why. So what happens is this is where it's impacting the most, and it's spinning, so one side of the sun is going to have a more impact and the other side is going to be sort of drifting away. And they show that. And then the helium will be forced up and down as the impact scrubs through. And that's what creates the corona. Out here it's millions of degrees in the corona. Right on the sun surface, 6,000 degrees. A 5-year-old will tell you that's impossible. It's impossible. If there's nothing out here to scrub to, there's no reason this should be energetic. It's zero. Heat goes away from its source. 6,000 millions? No. It's because it's scrubbing through the particles in space, which are light, which I showed you accelerate. A million times I've shown it. They're particles. It's time they have to just stop eating up the dogma. As far as I'm concerned, dogma poop. All right, I'd love to work with this guy, Brian Rolfe. He's only got 602 views, but 6 years. This is fabulous. Watch this. What happens here is they're reflecting light rays backwards and turning it back into a Venturi coming backwards at us and into the camera. And in the middle you can put something at which the light being accelerated will show up energetic particles. But the black particles are the non-energetic. They won't ever show up. And here's what happens. Watch this. This is so cool. That's a candle. Now it's called a Schillren of imaging. Now, watch. You see that? That's the energy. You see that? That's the non-energy. When I never realized, I thought I don't know what I thought, to be honest with you, because my mind just keeps changing. But I can see now that is energy pushes non-energy away. Energy pushes non-energy away. That's what happens. Energy pushes non-energy away. And that's, now I finally realize that is what's happening. It's not just that they moved them away. And so these are like two different states of matter. These are not really attached to these. They want to be touching each other like a magnet touches another magnet, but whenever there's heat or energy or so forth, you lose your magnetism. And that happens in a magnet too. If you have a magnet and you heat it up to a certain point, it loses magnetism, just like this. Originally those two were together. Okay, once you heated it up so hot, they started to break apart. It's pushing the black from the white. Now it's starting to make sense. Watch. See that? That's strictly energy. That's strictly not energy. There it is right there. Boom, bang, ding, dong, done. And I realize why that razor blade is what causes this effect to be so brightly white and this not anything at all. Because the only light that's coming through here is the white. And it's concussing the other white, which is pushing away the black. Now those are vapors from your hand. They're mixed together like clouds in the air. Now when you're doing serious, all right, this is butane, all right, which is a gas, C4H10. All right, it's the carbon hydrogen. Now you can see what's happening here. You're separating particles from other particles. So there's some bonding going on, and there's some strips of polar molecules. There's one from Harvard that's outstanding, but they have a big copyright thing on there, so. Now, watch that. There it is. There's your black, and there's your white. The heat forces energy to separate. Now, it will separate according to the attractiveness of the earth or the repulsiveness of the earth. Now, when you have extremely concussive, expansive gases of the white particles, I believe they push away from Earth. Normally they are attracted to Earth. These are what I would consider to be the negative particles, which is like static electricity would collect on you. And I can see them completely separating from the black particles. So as far as I'm concerned, this could very well be dark matter, which they have been looking for forever. And they found out that this, they know there's two different sides to this thing. And they know there's dark and they know there's a strong and a weak, dark and a white. And they found out that it's called Lepton Universality, which is the leptons have to equal each other. And they found out they don't. By a certain percentage, they think. Now, I don't know anything about that, but I can tell you what, these particles appear not to be, I was thinking they're the same particles and they cannot separate really, but now I can see they're just totally separate. That's the gas being released from like carbon dioxide or something coming out of there. But it's under pressure, that's why. Now, if that gas was not under pressure, there's no push to shove, there's no glow. It's always, always, always impact, push to shove. Difference in temperature, let's put it that way, because it can be extremely subtle. The guy's hand makes a change. So it's because what his hand is doing is making the water molecules in the air change their polarity, basically. Now, if you look real carefully, you see these little dots. Those are, there's some kind of a molecule or an atom that's reacting there. Because right in the dead center of it is a little white spot. And then, so you have your white, you have your dark, and then you have your white again. And that's what these particles are. Now, I think this is on the camera lens. So when the light comes through it, it excites that particle and you see it. Now here's, whoops, outstanding. And that's the Schillerin. Now there's one, hold on a second.
Last week I showed you guys how to win over your hot neighbor through snowflake preservation, but I realized that I never showed you guys how to determine if your neighbor is actually hot. Today I'll show you how to construct a device that will let you see heat coming off your neighbor and thereby reveal their hotness. We'll be building a Schillerin system, an apparatus for viewing differences in air density that would normally be invisible, such as rising pockets of hot air.
You see how subtle you're seeing?
I'll show you.
And the reason for that is that when heat comes up, it comes up just like this. They separate these particles. Anytime you concuss or heat or impact or a chemical bond is broken, you get a glow, which is what we're seeing, because that glow is getting hit with only the white particles. So we see the glowiness coming off, but nothing else. And the tiniest bit of change is
So
seen.
you got some other cool examples at the end.
You see that?
Here's what you're going to need. A parabolic telescope mirror, minus 6 inches. Guys, shush, that's completely average, it's okay. But for this project, bigger is better. A camera, a telephoto lens.
That mirror is like a dish-looking thing, so that it's when you hit it like this with light, it's a dish, so it's gonna reflect. Instead of reflecting back this way, it's gonna reflect back this way. And then at 2 times, I think it's something like that, the distance of the dish radius type thing, it'll hit a point. And that's where you have the razor blade. And when you have that razor blade, that point of all of those photons coming together in that one spot, you end up with the exact same thing as this. And the black ones get out of the way, and now the white ones are hitting the flame and all that sort of stuff. And the camera's behind it picking it up. And that's what they're seeing, and this is how you make it. All right, so don't forget, let's go back to what he's showing you. You need a parabolic mirror. Right there. It's a dishy looking thing. You don't see it it looks like it's flat, but it's not. All right, here he goes.
Here's what you're going to need. A parabolic telescope mirror, minus 6 inches. Guys, shush, that's completely average, it's okay. But for this project, bigger is better. A camera, a telephoto lens, a point light source. I made mine out of a bright LED coupled to some fiber optic, and a razor blade or some sharp edge.
The sharp edge is so that when the light concusses with it, all that's going to be let go by is the white. The black is going to get out of the way, and that's why they do the double slit experiment with sharp edge things. We did it with a Venturi, rounded things. And what that did, it accelerated the light, just like it does across an airplane wing or through a carburetor or anything. This is just blowing the black stuff out of the way and letting the white stuff continue on to really give us a strong picture of the excited particles, because they're the only ones that are ever going to light up. So we're hitting them with another beam of high energy particles that have been split off. The black ones get out of the way. The white ones continue on, highlighting our, now that you have some idea what we're doing here, well, let's let him continue. He's pretty good, this guy.
Gather all your items and find a large open space. We want to create an optical path where our mirror focuses light from our point source almost directly back at it. A long focal length here is desirable, but it also means you'll need more space. Before we go any further, we need to understand how Schillerin systems actually work. Schillerin systems operate on the principle of refraction, that light will bend when passing through media of different density. Refraction is responsible for mirages, Pink Floyd album covers, and pretty much every microchip currently produced. You've probably even seen it in a kitchen or chemistry class as well. In a Schlieren configuration, refraction is our friend. When light passes through air of higher density, it refracts and passes to one side of our focal point. Likewise, light passing through less dense air will bend slightly in the other direction and pass to the other side of our focal point. Placing a razor blade at our focal point will block half the light, but otherwise leave our image unaffected. The consequence, however, is that light that refracted through the less dense air gets completely rejected, and light that refracted through the denser air gets passed. This simple effect leads to some pretty amazing results. When setting up a Schlieren system, it's
All right, let's look at that again, because I think he's missing something that, is hard to understand, but we know that when you impact something, we can see the white particles move away from the black particles. So I believe when it hits the razor blade, there's so much of an interaction there that just like here, it's pushing all the black ones out of the way and letting the white ones come through, because they, as we saw, they go straight through the Venturi. They're going to go straight through that, and they're going to accelerate. And they are going to be high powered, and the black ones are not going to be with them.
that refracted through the less dense air gets completely rejected.
See, completely rejected, correct, by the razor. This less dense, these are the dark particles, is what it is. These are the energetic particles. It allows them to go by. The black ones get pushed out of the way. Now, I don't know if they understand it. And this is the parabolic mirror. So when we hit it with a ray like this, it comes back to a point like that. And then the razor, at that point, it's exactly identical to our Venturi. Only they're using a razor. I'll bet you if you used a Venturi here, wow, I can't imagine what you'd see. Wow. Because you got already, now you can use all this light. I'd love to see that. Anyway, what it does is it gets rid of the weak particles, and it lets the more dense, which we're going to call the energetic particles, the less dense are the weak particles. That's all it is. Now, I guess they sort of understand it, but I'm not sure they... Well, I don't think they've... Let me put it this way. I don't think they've ever seen this. Let me show you what I saw and what they need to see. I think the term is Eureka. And what am I referring to? I'm not referring to a smell. I am referring to light separating the dark part from the white part. And what is that all about, Roger? Well, it shows exactly the same effect in the Schlieren imaging photography I was studying, and I'm going to show it to you in a minute. It separates the black from the white, and because I'm trying to understand, and nobody could tell me why the razor blade would cause the effect that you see, which is to completely isolate white particles from black particles. And the white particles are in heat, and the black particles walk away from heat. This is nothing more than heat. This is nothing more than particles being crushed or burned or combustion or breaking the bonds and releasing electrons. It's nothing more than energy. And when energy happens, the black balls walk away from the white balls. Originally, they were just like this when they came in there and hit. And the black part walked right away. They have to be together like this. You have to have a black and a white. That's an electron. When you have two of them together, they create photons. The photons will heat you up and warm you up and give you energy and do, make plants grow and do all those kind of things, but they won't burn you up. These will burn you. This is electricity that is absolutely electricity. These come through the atmosphere as lightning. Electricity, right to ground. Static electricity, these are attached to big molecules, primarily water, vapor. because water vapor is a highly polar molecule, H2O. It's polar. It's like a bar magnet, and these attach. When you walk through that water vapor and it's looking, if there's not enough water vapor for one of these to stick to, it'll find you and it'll stick to you, and then you go to a water pipe, bam, right to Earth. And it will shock you because it creates such an energetic reaction because it's only a half. A photon is the full. An electron is a half. And you can push this with electricity or pull it with electricity, either way. But that's the only thing that exists. So when they say there's a proton or a neutron, a proton is 1837 of these particles, and 1838 of these particles makes a neutron. Think of it that way. So a hydrogen has about 1840 of these particles, makes a hydrogen. Then you go to a helium, has 7,352. All right? That's a pretty big jump. Then you go up from there, lithium and so forth, up the line until you get up to gold and lead and all that. There's bazillion, trillions of them in there. I don't know how many there is. But somebody's going to have to do this and look at it in this way, because I finally realized anytime there's a concussion, the blacks get out of the way. The whites just keep on going. Just like this, they shoot out of the way. Well, what is happening? The razor blade is here. It's hitting the razor blade and boom, pushing all the black ones. But then the white ones continue on and really interact with anything energetic, and the flame is energetic. And it interacts with the white part of the flame, which is the concussive, explosive part. Because the black ones, remember, they just float around. They don't care. They'll just lay around. They are going to get out of the way. So you're going to see when this white stuff comes through, it interacts with the white of the flame and doesn't do anything with the black. The black is just going to stay where it would have been anyway. We normally would see a big white, well, I'm going to show you in the flame because it's just so cool. All right, there's the pulse red laser. There it is accelerating, and it's showing itself as a particle. Einstein was wrong about this stuff. I'm sorry, that's just what happened. Then it turns into the separation of the different charges, the weak charge and the strong charge. And here they were just before they hit the Venturi, separating and only allowing the white stuff through. Only allowed the white stuff through. You see it? I believe this is why they're seeing that effect they're seeing. Because the black stuff is getting out of the way and only the white stuff is getting through. And then they have their candle right here, and what do you call it, a photo here, and it's imaging on there. Now, anything that's black coming up from the energy, where it's separating, with a candle, where we got one white side, one black side, the only thing that's going to be highlighted in our picture is anything that's energetic. And we have no other particles in here other than the ones that are being produced coming up. So we're only going to be highlighting the energetic particles in whatever they do energetically. If there's no energy, there's nothing happens. You look at it, it just looks like nothing. But if the guy puts his hand there, there's heat vapors rising. If they put a hairdryer in there, all kinds of bubbles flowing out of there. If they put anything that has energy or has a different density than what this air is, it's going to hit it as a energetic reaction, and energy shows as white. That's why we see these white things. All right, I hope I had that in focus enough that you saw the light accelerating, and you saw that the light is a particle. It's made up basically like that. It's got a white and a black ball glued together side by side. And they're two electrons, really, so they're neutral. They come through the air and they bounce off of things and they excite things. But it's not like electricity going through the air. Electricity going through the air goes, and it burns things. This is what electricity is. It's half of one of these. All right? And then when two of them or four of them get together in a clump, they start to make matter, and they start with light. Light is the smallest particle that is stable outside of an electron. Electron always wants to be attached to something. They will be attached to water molecules in the air, extra electricity, and you'll walk through the air and you will collect them on you as static, and then you'll touch a pipe, bam, right to the earth, because the earth is a attractor of these particles, the explosive particle, the white particle. The black has no interaction, it just wants to be with the white. It will not explode like the white is exploding. You see the black balls here? You see them? They were coming through like this, black and a white together, and then all of a sudden, in the Venturi, it won't allow the blacks to come through here. It just, all the white explodes in here, and the black balls come back to attach to the white particles and begin to make matter again, which is the photons of light, or whatever. But I can find now that we can detach the black particle from the explosive white particle. And I've seen this now in thin film photography and soap bubbles, believe it or not. I believe I can see dark matter, which this could very well be dark matter. It is dark. It is part of the particle. It was part of that particle. And it went away from the explosive part of the particle, and now it's coming back to it. Now, even when you walk through the air, you collect this on you, that's attached to it. It doesn't do anything. But you get close to the ground and pow, that goes right in. If you push electricity, which is a potential, all it is a magnetic potential, it will push these magnetically or pull them magnetically. And that's all AC power is. Push and pull, push, pull, push, pull, push, pull. 50 cycles over in Europe, 60 cycles in the United States. Boom, 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 boom. So it's pushing and pulling back and forth the electrons. That's all it is. And that's what this is. All right, you take these from, they're almost like a water out of a hose. And you can put it, you can hold it in the air and it doesn't have anywhere to go. But if you go to the ground and you get it close enough to the ground, a wire with electricity in it, it'll go right to ground because it wants to join the electrons that are being sucked into the ground. That's what gravity is. And it happens because of our scrubbing through the atmosphere of space, which is ether. There's ether all the way around the planet. Everywhere in space is ether. They say, oh, there's a microwave cosmic radiation background. No, it isn't. That is all the light from all the luminous bodies that are just floating through the atmosphere and through space. You can't stop it. Our sun is spitting them everywhere. What do you think? They just don't go anywhere? Obviously they go somewhere, and they're out there just floating around, and we call them ether. We scrub through that with our magnetic particles, which are photons of light and gases and so forth. And these magnetic particles scrub through these magnetic particles, creating electric field up through our North Pole, from the South Pole up to the North Pole and back around into our planet, called gravity. All right? And we are growing. The Earth is, oh no, we're hydrogen and helium is just drifting off the Earth. No, it isn't. It's being pushed back down into the Earth. And they just released a thing that shows electron flood theory. I can explain it 100%. They have no clue about it. It's about helium being missing from the equatorial regions. I'm going to read this to you. I have a buddy, he's with NASA and the European Space Agency. I think he's retired now, but he we go back and forth, and we're talking about light and about thin film photography, and about, he was showing me something, how they're analyzing plants now using all the different capabilities they have now with light imaging and all of this. I'll show you to you.